I'm Giovanni Bechis, CEO of SMB. We are a software house that works mostly on mail servers, both as developers and as hosting providers. And uh, today we talk how we scale. We decided to use Puppet to scale our anti-spam solution. Firstly, I CEO, sysadmin, developer at SMB, which is my software house. I am OpenBSD committer for more than 10 years. Apache SpamAssassin committer, Apache HTTPD committer, random patches in a lot of software that are integrated in the mail software area. We work together also with some customers to anti-spam as a service software that's based on our Apache SpamAssassin, other tools, and it's managed by Puppets. The mail software we manage using Puppets is all the software that is used or on our anti-spam solution. Anti-spam is not only mail, but it's a full stack of a lot of softwares. So we have a DNS server to properly cache DNS requests. We have ClamAV as an antivirus for to check incoming and outgoing emails. We have Postfix and OpenSSN TPD to send real emails. We have OpenBSD SpamD as gray listing software. We have Redis as caching for some internal use. We have Apache SpamAssassin. We have Mimedefang, which is software we're using as filter to interface Postfix with Apache SpamAssassin. We have Filebeat to send log files for later analysis to ELK, Elasticsearch, and Kibana. And finally, we have Zabbix to monitor all the stack. All this software is managed by Puppet using some modules available from Puppet Forge, but a lot of modules we created from scratch, because the ones that were available on Puppet Forge did not perfectly fit our infrastructure, or in more common case, they were not supported in OpenBSD. The idea in the end of the development is something we have on our to-do, is to change our infrastructure and move to something that can be available on Puppet Forge. So we're going to release our modules on Puppet Forge to be all open source. We have to generalize some code because in some cases it's too strictly connected with our infra. The first things set up is DNS servers. Every mail server must have a local DNS caching server. This is also because on many real-time blacklists, DNS queries coming from very commonly used DNS servers like Google One, Cloudflare, 48 or 41 are not allowed. One other reason is that we're using S.r.l DNSD, quindi so local real-time blacklist, and we had established zone on every RBL to connect to our RBL server. This is because this way I'm bound with cache requests, and all servers will not connect to the same. We could use caching also for RBL queries. RBL queries are used to check emails, so there are a lot of those RBL queries. What we used a lot in our Ruby code is Puppet Fets. In particular, a couple of things that are OS.name, because we're currently running our software both on Linux and on OpenBSD, so we have a lot of code that should check OS.name to differentiate between several different Linux distribution and versions, and between OpenBSD as well. One of the things is processors.count and memory system total bytes to correctly scale both ClamAV and Apache SpamAssassin. Some configurations could be improved and could be different if there are many processor or different memory on server. So for some customers, we have some sending machines with very few memory, so we have to adapt. The configuration is adapted to those machines. On some others, we have a lot of memory, so we use it to change configuration on the fly. For example, one of those is with ClamAV. We have a number of threads that ClamAV use, and and there could be different if we have more than one processor on the VM. Same for the correct path for the local socket, for example. That's different for several operating systems. One of the things is, well, we use a lot of ERB templates. Quite all configuration files are ERB templates. So we are able to change, like in this case, configuration values, counting. That depends on total memory that is available on VM. For example, in this case, this is the maximum memory that can be allocated to a SpamAssassin process. That can be lowered in some cases where memory is not that huge. We have a Redis server for internal use. Actually, we store our real-time blacklists data in Redis that then is deployed on the RBL DNSD servers. So we have automatically in Puppet configured our Redis master and slaves. And this is also with the ERB templates. One very important thing is that our Puppet server automatically check out code from our Git repo, and where it puts updated configuration files. A lot of configuration files are just static configuration files. For example, we have some lists of phishing URL. We have some list of hacked accounts for some ESP providers. We have a lot of static configuration that is both downloaded for external sources and automatically generated from some internal code. Uh, this is one example of something we've done. It's about OpenBSD SpamD. SpamD is a gray listing daemon running on OpenBSD, and it's based on PF, which is the OpenBSD firewall, and the code just checks and reloads configuration if uh, a test goes well. And we have this is a gray listing demo that gray lists only some servers that are downloaded from commonly available URL, and it's a great addition in the infrastructure. A very similar code is what we use to deploy SpamAssassin rules. We have both rules and data. Um, the sendingblue ID.txt, for example, is a list of sendingblue abused accounts. So when parsing the email, uh, we can be able to recognize if an abused account is sending and uh, rejecting the email, as well as we can load the rules we are changing. Some rules are changed uh, by hand by me or our developers. In this case, such rules are automatically generated. In SpamAssassin, there's some code that checks um, emails, spam emails, and ham emails, and automatically generates regular expressions that matches only spammy emails, and automatically creates rules for that. It's a very interesting addition, and it's something that it's very easily integrated with Puppets and very easily deployed to all needed servers. Uh, Mimedefang is the filter we use to deploy to interact between postfix that receives the emails and all the other anti-spam solutions. Mimedefang is a software that is as a part of code that changes that can be modified. That's the filter code that's written in Perl, and it has a lot of dependencies like SpamAssassin, clone some Perl modules. So on our Mimedefang Puppet module that we're going, I hope soon, to publish on Puppet Forge, we're able, all the dependency tree is respected. So once the Mimedefang model is installed, all the dependency tree is automatically installed and configured. Uh, the code of Mimedefang is Perl code. We have some internal code that changes the Perl code we're using testing machines to an ERB template in order to be able to configure differently configure for different machines. This is an example we use in Mimedefang. There are some parameters. Mimedefang is strictly connected with SpamAssassin. So we have the Mimedefang module installed on SpamAssassin.cf file, which is configuration files with correct username and password that are then used to query configuration on our MySQL database for single users, like the level of the spam after which mail should be rejected, and if in which cases the subject of the email should be changed, and some other configuration. The other part is strictly related to Mimedefang. So some configuration where it are passed, like how Mimedefang should behave, like virus clone D is if uh, the Mimedefang should connect to ClamOv to check for viruses, if it should check yes with SpamAssassin for spam, or with SpamC, which is the demonized version of SpamAssassin. If it should check for bad files inside zip files, inside RR files, and so on. This is done in ERB code, so our software changes the simple script changes uh, the Mimedefang filter code into an ERB template, and it uses any changes, some things with the values that are passed from the manifest, some other things that are strictly connected with our infrastructure and cannot be easy and should not be changed on a per manifest basis, and should not be easily changed because, for example, they are connected with other part of the infrastructure. I'll save it to Jira. So we use Jira as a storage for informations from Mimedefang that cannot be easily changed, or the variable part are inside can be changed from the manifest, or the static part that are not so easy to change because they involve changing other parts of the infrastructure, are saved into Jira. We're using Filebeat to deploy, to save and analyze log files. We're using this to check for log files, but also to understand how anti-spam is going. So if some bad emails are are badly checked, and we have some false positive, or if we have some false negatives, we have some code that asks Elasticsearch for some and tries to match if some emails are badly checked. For example, if they match a whitelist, but they also match a blacklist, it's something that it's a warning for us because there's something wrong that's going on, because it probably means that the blacklist is wrong or the whitelist is wrong. This saves data from both Mailog and SpamD, so and also other sources or our infrastructures like web servers and so on. But the manifest is something very similar to this one for all kind of servers. One other thing is we manage from scratch is the Zabbix configuration. There are some Zabbix module on Puppet Forge. In the era when we began, there was nothing that supported OpenBSD. We decided that it was easier to write from scratch something, but the plan we have is definitely to use Puppet Forge for this model and for other models as well, and try to standardize all the code, use as many Puppet Forge models and contribute to Puppet Forge, and open source the models we wrote that make sense to open source, or that we can provide as generalized as possible. This is mostly done with what we use in to scale our anti-spam solution. At the moment, we have all in place, and it's just a few click to add many servers. So it's all also fully automated thanks to Puppets.